Welcome, middle school algebra students. This is lesson 3.2.2. How many solutions are there? In lesson 3.2.1, you reviewed your equation solving skills to remember how to find a solution to an equation. But do all equations have a solution? And how can you tell if an equation does not have a solution? Today you will continue to practice solving equations and will continue to investigate the meaning of a solution. Today we will be working through the 6 equations that are in problem 3-81. Let's start with problem 3-81a. 4x minus 5 is equal to x minus 5 plus 3. Now you can build this equation using an equation mat in your eTools if that's what you would like to do. If you would like to set that up, pause the video now and build this equation using your eTool. All right, I'm going to write a line through the equal sign to show the left side and the right side of the equation. Now I'm going to look at the left side of my equation, 4x minus 5. Nothing I can do with that yet. On the right-hand side, I see here I have 1 x tile plus 3 x tiles is 4 x tiles. And I also have 5 negative tiles. Now what I did to get this step is I combined my like terms or combined my like tiles. I put the 3x and the 1x together to get 4x. Now, when I look at this, I would remove identical tiles. So I have 4x's on the left and 4x's on the right. So I would remove 4x tiles from both sides. And now when I remove those, I see here that I have 5 negative tiles on the left and 5 negative tiles on the right. I could also remove those and be left with 0 equals 0. Now, what you notice here is there's no x left in the equation. So what that means is there is not only one solution to this equation. And because the left side is equal to the right side, either negative 5 equals negative 5 or 0 equals 0, this tells us that all real numbers are a solution to this equation. So there isn't just one solution, like x equals 2 or x equals negative 3. All real numbers are a solution to this equation, meaning no matter what number I put here for x, the left side will always equal the right side. Now let's take a look at 381b. Again, if you would like to, open up your eTool and draw this equation on an equation mat. Pause the video now if you'd like time to set that up. All right, to solve this equation, I'm going to look at the left side of my equation. Here I have 1 negative tile, x tile, and here I have 4 negative x tiles. Together then, I have 5 negative x tiles. I also have 7 negative unit tiles. On the right-hand side, I just have 2 negative x tiles and 5 positive unit tiles. What I did here, again, was combine my like terms or combined my like tiles. Now I can see that on the left-hand side, I have 5 negative tiles, and on the right-hand side, I have 2 negative tiles. I can remove identical tiles. So I can remove 2 negative x tiles from both sides. So I'm going to remove 2 negative x's from the left and from the right. So if I had 5 negative x tiles and I remove 2 of them, now I have 3 negative x tiles. I still have the 7 negative unit tiles. And now on the right-hand side, now that I removed those, I do not have any x tiles on the right, but I do have 5 positive unit tiles. Now looking to solve this equation, negative 3x minus 7 equals 5, I know that eventually I want to get the x's by themselves. So I want to remove these 7 negative tiles. Well, the way that I'm going to do that is I'm going to add 7 tiles to make 0 pairs. And if I add 7 tiles to the left, I must add 7 tiles to the right. So here I add identical tiles. All right, so what do I have left? If I remove these 7 0 pairs, I have 3 negative x tiles on the left, and now I have 5 plus 7, or 12, on the right. I got there by removing the 0 pairs. Now what I'm going to do is divide my x tiles into 3 piles. So I divide by 3, and here I get each negative x tile is equal to 4 unit tiles. Now keep in mind when we're solving the equation, we don't want to know what negative x is equal to. We want to know what positive x is equal to. So if negative x is equal to 4, then positive x is equal to negative 4. So this equation has one solution, and that solution is x equals negative 4. Now here is a second way that you could solve 381b. And one method is not better or more correct than the other. It's just a different way of solving. So here I combined my like terms to get negative 5x minus 7 equals negative 2 plus 5. That's the same that I did in the first method. But here, instead of removing 2 negative x tiles, I added 5 x tiles to both sides so that I could get these 0 pairs here. So when I add 5x to both sides and remove these 0 pairs, now I have 7 negative unit tiles on the left, and now when these 2 positives cancel 2 of the negatives, I'm left with 3 x tiles on the right and 5 unit tiles. Now to get here, I would add 5 negative tiles to both sides so I can have 0 pairs here, leaving me with 3x, and then negative 7 and negative 5 leaves me with 12 negative tiles. Then instead of having 3 x's, I divide them by 3 piles to get 1 x. And when I divide both sides by 3, I get 1 x is equal to negative 4. Same solution that I got in the first method, just another way of approaching the problem. Now let's take a look at 381c. Okay, I'm going to draw a line through the equal sign. And now here on the left side, I see here that I have 5 positive x tiles and 7 negative x tiles. Well, if I combine those together and remove my 0 pairs, I see that I would have negative 2 x tiles. And then 3 positive tiles and 4 negative tiles. Again, if I took away those 3 0 pairs, 3 minus 4, I'd be left with 1 negative tile. And on the right-hand side here, I have 2 x tiles minus 4 x tiles. That would leave me with 2 negative x tiles plus 1. Again, how did I get here? I combined my like terms. You could also say that you removed your 0 pairs. Okay, now I have 2 negative x tiles on the left and 2 negative x tiles on the right. So what I would do here is I would remove my 2 negative x tiles from both sides. And when I do that, I see here when I remove those, I see that I have no x's left on the left and no x's left on the right. So I'm left with negative 1 unit tile on the left and 1 positive unit tile on the right. Now I see here there are no x's left in my equation. So I know that the answer is not just one solution. This is either there is no solution to the equation or all real numbers are the solution. Now look at what we're left here. We're left with -1 equals +1. Well, that is a false statement. -1 does not equal 1. Therefore, we say that there is no solution to this equation. In other words, there is no number that you can put in for x up here where the left side would equal the right side. It's just not possible. There is no solution to 381c. Now let's take a look at 381d. I'm going to draw my line through the equal sign. And now in this problem here, I see that this equation mat has a negative, it has tiles in the negative region. So the very first thing I am going to do is remove those tiles from the negative region. And when I do that, I would still have 4 x tiles in the positive region. But I would take these 3 negative x tiles and flip them to the positive region. That would make them positive. And I would take the 2 positive tiles out of the negative region, flip them to the positive region, and that would make them negative. And now on the right-hand side, I still have 7 x tiles and 2 negative tiles. Now, what I did here, I would say that I flipped my tiles from the negative region to the positive region. Okay. Now on the left-hand side here, I see I have 4 x tiles plus 3 x tiles. I'm going to combine them. So I have 7 x tiles and 2 negative unit tiles on the left. And on the right-hand side, I also have 7 x tiles and 2 negative unit tiles. Again, to get here, I combined my like terms. Now, you may have already noticed that the left side, 7x minus 2, is the same as the right side, 7x minus 2. So what we could do here is remove 7 tiles from both sides. We can remove our identical tiles. Okay. And let's look at what we're left with. When we remove those identical x tiles and we take them away, now I'm left with 2 negative unit tiles on the left and 2 negative unit tiles on the right. I could also remove those identical tiles to get 0 equals 0. So there is no x left in this equation. That means there is not just one solution to this equation. This is either a no solution or all real numbers. And because what I'm left with, 0 equals 0 or -2 equals -2, is a true statement, that tells me that all real numbers are a solution to this equation. And in other words, no matter what number you put in for x here and here and here, if you solve the left and you solve the right, both sides would be equal. So the solution to this equation is all real numbers. Now let's take a look at 381e. X plus 3 plus x plus 3 is the same as the opposite of x plus 4 plus 3x minus 2. The first thing that I notice is that I have tiles in the negative region here. So I am going to take the tiles and I'm going to move them out of the negative region. So x, when I move it out of the negative region and move it to the positive region, would become -x. And positive 4, when I flip it to the positive region, would become -4. I also have now in the positive region this 3x and 2 negative tiles. On the left-hand side, I just have x plus 3 plus x plus 3. There were no tiles in the negative region here. So my reason here is I flip tiles from the negative region to the positive region. Now I'm going to combine my like tiles. On the left side, I see I have 1x here and 1x here to give me 2x. And I have +3 and +3 is +6. On the right-hand side, I see here that I have a -x tile and 3 +x tiles. So I can combine those, remove my 0 pair that I have with the 1 negative and the 1 positive, and -1 plus 3 would leave me with 2x tiles. And then negative 4 minus 2, or 4 negative tiles and 2 negative tiles, is 6 negative tiles. So again, here I combined my like terms. Could also say that you removed, and you also removed a zero pair. All right, now I have 2x plus 6 on the left and 2x minus 6 on the right. I can remove identical tiles from the left and from the right. So I can remove 2x tiles from the left and from the right. So I remove my identical tiles next. And now I remove them. And now all I'm left with is 6 positive unit tiles on the left and 6 negative unit tiles on the right. So here, again, I have no x left in the equation. So I know that it's not just one solution to this equation. And now, because 6 does not equal negative 6, that tells me that there is no solution to this equation. In other words, there is no value that I can substitute in for x here and then solve where the x side would equal the right side. There is not a number that makes this equation true. Therefore, we say that there is no solution to this equation. And last, let's take a look at 381F. I'm going to draw my line through the equal sign here. Now the left side says x minus 5, and in the opposite region we have 2 and a negative x. And on the right hand side we have negative 3. So the first thing that I'm going to do is remove these tiles from the negative region and flip them to the positive region. So that would leave me with an x and 5 negative tiles still in the positive region. Then when I flip these tiles from the negative region to the positive region, now I would have 2 negative tiles in the positive region and a positive x in the positive region. And on the right hand side I still have 3 negative tiles. So here I flipped my tiles from negative to positive. Now I'm going to combine my like tiles on the left. So I have 1 x here and 1 x here, leaving me with 2 x's. And I have 5 negative unit tiles and 2 negative unit tiles. So together I have 7 negative unit tiles. And on the right hand side I still have 3 negatives. And to get here, again, I combined my like terms, or my like tiles. Okay, now my goal is to get x by itself, but I have these 7 negative tiles on the left hand side. So what I'm going to do now is add 7 positive tiles to both sides. So that's called adding identical tiles. So now I can remove these 0 pairs to be left with 2x is equal to, now over here I have 3 negative tiles and 7 positive tiles. So I could take away 3 0 pairs and that would leave me with 4 positive tiles. So again here I removed my 0 pairs. Now if 2x is equal to 4, I want to know what is 1x equal to. So I take my x tiles and I divide them into piles of 1. So I would divide by 2 to get that 1x is equal to 2. So there is one solution to this equation, and that equation is x equals 2. And what that means is when I put a 2 in for x here, and I solve the left side, it would equal negative 3. So our solution to 381F is x equals 2. The math notes box in lesson 3.2.2 reminds us about circle vocabulary and circumference and area. So a couple of reminders here. A radius of a circle is the line segment from its center to any point. So from the center to any point on the circle is called a radius. If you're going to talk about more than one radius, we call them radii. A chord of a circle is a line segment joining any 2 points on a circle. So this is an example of a chord. The diameter of the circle is a chord that goes through its center. So the diameter is here. Keep in mind that the length of a diameter is twice the length of a radius, because here is a radius, here is a second radius, and together they make the diameter. And the circumference of a circle is its perimeter, or in other words, it's the distance around the circle. So the circumference is talking about this distance here, around the circle. And the rest of the math notes here remind us that the formula to find the circumference of a circle is circumference equals pi, which is about 3.14, times the diameter. And to find the area of a circle, we take the radius and square it, or in other words, the radius times the radius, and then multiply it by pi. Another way you will see it written is area equals pi times radius squared. All right, middle school algebra students, your homework is on pages 129 and 130. This is the review preview section. And your homework is 384 to 388. Have a wonderful rest of your day.